So, question 7, we're given y equals 3x squared plus 24 over x plus 2, where x is greater than 0. Part A says find dy by dx. So we need to differentiate our expression, but before we do that, again, we don't like this fraction. So y equals 3x squared plus 24x to the minus 1 plus 2. So that's your starting point. Convert it. Then we can differentiate it. So dy by dx, bring the power to the front as a multiplier, so 3 times 2 is 6. Drop the power by 1, x. Bring the power to the front as a multiplier, so minus 24x, drop the power by 1, minus 2. The plus 2, when you differentiate it, it's constant, so it goes to 0. Now, just to make this a little bit easier for ourselves, let's convert this back into fraction notation. So x to the minus 2 becomes over x squared. Okay, you'll still get all the marks for this, but this is going to be useful to us for part B. Now, part B says find the range of values of x for which the curve is increasing. So if the curve is increasing, then we know something about its gradient. So the increasing part implies that the gradient must be greater than 0, must be positive if it's increasing. So therefore, well, we know that the gradient is related to dy by dx. dy by dx gets us the gradient of the curve at a given point. So that must be greater than 0. So dy by dx must be greater than 0. Well, we have an expression for this. So we can substitute in 6x minus 24 over x squared is greater than 0, and then we just need to rearrange this. So 6x is greater than 24 over x squared. X cubed must be greater than 24 divided by 6, which is 4. So therefore, x must be greater than, moving the cubed over, the cube root of 4. Now, we can show this graphically, but the question doesn't ask you to, so as long as you can rearrange this, it's about understanding what the increasing implies to the gradient, and therefore dy by dx, and then just being able to rearrange that equation. So that gives us our range of values. Now, noted, it does tell you that it's a range, so you would expect an inequality to be in there, not just a singular value. Moving on to question 8 then, we want to use and find the binomial expansion for the first 3 terms for 2 plus 3x over 4 all to the power of 6. Now, for this one, it's telling you it's a binomial expansion, and you should recognise if there's a higher power there, you're going to need to use the binomial expansion. So this is when you go to the formula sheet. You go straight to it and then you apply that formula. And all it does, you take the first term, 2, raise it to the highest power, 6, plus, then we're going to use a little bit of notation where we have our power, and then we've got 1 there, times our front term, 2. Our power's going down by 1, so it's the power of 5. We take our second term, so 3x over 4. That's the power of 1. You don't have to put the 1 there, but it is the power of 1. Noted these powers will add up. Plus 6, 2, 2, dropping the power by 1, 4, 3x over 4, raise the power by 1, 2, again your powers add up to 6 there. And we can put a plus dot dot dot, but it wants the first 3 terms, so you don't need to go any further than that. And actually, if you do, not that they're likely to, but they could deduct your marks because you haven't properly read the question if you put the 4th, 5th, and so on terms. Now, these 6.1 and 6.2, you've got a button on your calculator that helps deal with that, and you need to remember that's your NCR because it's about the number of combinations, okay? So you need to make sure you find that NCR button and substitute in accordingly. So, when you substitute in, you end up with 64. you've got 2 to the power of 5 times 3/4, and you've got 6 NCR1, which gets you plus 144x, x to the power of 1. 6 NCR2 times 2 to the 4 times 3/4 squared. Put that into your calculator and you've got 155 x squared plus ... Those are our 3 terms, and if you've got that, you get all the marks. Okay. Part B is then an application of the binomial expansion. Now, in the new syllabus, they quite often like to have these as an explain rather than actually find what the value is to so many decimal places. So it'd be part to give you fewer marks for understanding the same level of maths. So it says, explain how the above expansion can be used to find the approximate value for 1.925 to the power of 6. Well, the power of 6 gives you the clue that these are very much going to be equated, and they are, but what we can say is that we've got 2 plus 3x over 4, because that's raised to the power of 6 and the 1.925 is raised to the power of 6, is equal to 1.925. We can rearrange this to get a value for x, so we can say 2 minus 1.925 is 0.075. When you move the 3x over 4, make sure you have the minus there. And then you've got 0.075 divided by minus 3 over 4 gets you an x value of minus 0.1. The minus is very important. This value is less than the 2. So the value of the x must be a negative. Now, if you get that, we're nearly there, because the explanation says, well, what are you going to do with that value? Well, all we simply do is substitute it into our expansion. So that's just what we need to write. Substitute x equals minus 0.1 into the expansion. 64 plus 144x plus 155x squared to get an approximate value for 1.925 to the power of 6. So if we substitute that value into this expansion, it will get us an approximate value for the 1.925 to the power of 6 value that they're looking for.